Sudeep. Okay, so hope that that we will do a little bit of recap what we did in the last this one that we just went into the basics of electricity, right? Just the basics were the current, voltage, and resistance. Okay, today we'll look into a little more details of that one. Okay, so for starting, so we said that one, we did it this. Okay, so now let us recap. Let us see that how much we remember from the last week. Okay, so can you see what is the question and can you recollect what did we learn last time? Which of the following describes the current? So A, B, C, or D? Yes, Mega, Ritikesh. Yes, Shreya. Yes. So everybody remembers that one, right? The current is the flow of an electrical charge. That is the electrons when it is moving, that creates the electric current, right? Now, what was the resistance? What did we learn about the resistance? What does it do, resistance? What does the resistance create? What does resistance do in a circuit? Okay, Ritikesh, Megha. I want others also to answer. What did it mean that resistance in a circuit? You remember that we showed a water circuit and where is it creates an obstruction. Similarly, the resistance is the one which is for the which is creating an obstruction to the flow of electrons in an electrical circuit. That is what a resistance is. So it makes it hard for electrons to move through the circuit. And what was this one? Dash is the pressure from an electrical circuit's power source that pushes the electrons through an electric circuit. That's the pressure. What is that pressure? Recall in electrical terms. What is that pressure? That is an electrical circuit which forces the electrons to flow. Yes, guys? What is that? Yes, Hrithikesh, Shreya. What about others? What was that? Haripriya, yes. Santana, yes. Okay, so voltage was that pressure. You know, you saw the water pressure, that which allowed the water to flow. Like that, for the electrons to flow through an electrical circuit, it is the voltage which forces the electrons to flow. Okay. Now for the that we had the previous module assignment, right? That we had said that one, that voltage and wattage of 5 appliances. In the website, I got the answers from Amalu, from Harita, and from Hrithikesh. Okay, Hrithikesh has put all of the in separate slides, but I took only as a sample of that one. Okay, so what did when you found out? Did everybody look into that one? Everybody look into that your home appliances. What is the voltage and the wattage written on each one of them? Did everybody do it?
Yes, ma'am. Yes.
Yes. Okay. So now let's see how to read that one. Okay. Now, for example, I'm taking my example because I had this one. Okay. So for this one in the electrical iron box, it is written 1200 watts, right? Okay. The wattage, what is the relation between the wattage and this? 1 watt is equal to the voltage into current. Okay, so now in this one, iron box, we know what is the watt, right? 1200 watt it is written here. We'll take the higher value, okay, 1200 watt. And we know that the voltage is 240. So can you imagine what will be the current? Can you see what will be the current through this iron box? You can chat, put it in the chat. what will be the current? If watt is 1200 and voltage, you know, it is 240, take 240. Okay, how much will be the current in that one? How much is the current through this iron box? Approximately your iron box will have the same similar one. We'll go through one of the examples which you guys have shared. Okay, what will be the current through this? Because we know the value of watt, we know the value of voltage. So what will be the value of current? Anyone? I don't see anything in the chat. Yeah, Hrithikesh says yes, 1200 by 22, sorry, 220, 225. Yeah, if you multiply, if you divide it by 240, if you take the higher values, you get that one. Okay, so that is the 5 ampere is the current through this iron box. Okay, if you see on the screen, it is 1200 by 240, that is 5 ampere is the current through this one. Okay, what I'm telling you is to get the idea about what is this current in your home appliances. Now this is a bulb. Okay, then electric bulb, it is 24 watt was the wattage of this bulb, and 240 volt is the voltage. What will be the current through this bulb? This you can do it very fast, right? What will be the current through this electric bulb? You know, it is 24 watt is the, Hrithikesh, you're writing, okay, the 5 is for the previous one, right? Okay, what about this one? For the electric bulb, what will be the current through the electric bulb? Wattage is 24, voltage is 240. So what will be the current through it? Yes, it is 24 by 240, Hrithikesh, right? Because it is watt by volt will get you the current, right? Watt by volt will get you the current, isn't it, from this formula? So yes, Hrithikesh, yes, it is 0.1 because it is 24 divided by 240. That is 24 divided by 240. So that is the current. 0.1 is through a light bulb. You saw in the electric, in the iron box, it was 5 ampere. But in a light bulb, it's just 0.1 ampere. You see the difference? Now for the TV, this is one of the TV in my home. So this is 240 watts is the wattage of that one. The voltage is 240 volt. So what will be the current through this? This should be very quick. Yes, 1. Okay, you'll get it, right? So you can imagine that the current through a TV, it's around 1 ampere, but through a light bulb is only 0.1 ampere, and through the iron box, it is 5 ampere. That is how it differs in all equipments, how much current it is flowing. Everything is connected to the same plug, right? Everything is connected to the same plug in our home, which is giving 240 volt. But the current in that one varies according to the different types of equipment what we have. So all the equipments, you check your microwave, or you check your oven, or you check your the hair dryer, or any equipments in your home. All this one, everything, the voltage is the same, but the current varies according to the power required for that equipment. Okay, so the current in this one is this one. Now this was Harita who had done it, who had given me the, that her house, what will be the current and voltage. So I'll give you this as an assignment. What will be the, that what if it is 15 watt, what will be the current in that one? Okay. The oven. So since you got the idea, because since we'll be running out of time, I have to go a little bit this one. So for example, for the bulb in this one, if it is 15 divided by 240, you get in this bulb around 0.68 ampere. In this oven, 1500 divided by 220, you will get around 6.8 amperes. So in Harita's house, this will be the current in each one. Iron box, it is around 1400. So by 240, it will be around 6.5 ampere. In my iron box, it was around 5 ampere, right? So depends upon the equipment, different times, it will vary. For the fan, it was 55 watt. 55 divided by 240, you will get around 0.25 ampere. For the blender, it is 250 watt. And if you divide by 240, you will get around 1.13 ampere. You see the range of the current which is going through this one. What does that mean? That's what we will look into it right now. Okay. Okay. Now, just to recap from the last one, I just want to see just how the electron flows. You know that we said that one, the current is the flow of electrons, right? So this is how the electrons flows from in a circuit from one atom to the other. The electron will move from one point to the other. This is what creates the current, electric current. Now, for this electric current, you know that for this electrons, okay, you have learned that this electron has a charge for that one. Have you learned that one? I don't know if in which class you learned that one. You have learned that one, that each electron has a charge. Have you learned it? Can somebody unmute and say, have you done that one? Learned that each electron has an electrical charge? Maybe the younger children may not be, but by I think 7th and 8th standard, they should have it, right? Megha, did you have it? Did you learn it?
No.
No. Okay, what about the 8th standard? Have you learned it? The electric, what is the charge of an electron? Okay, so if not, then okay, let me explain. So see, in this each electron, okay, is having an electrical charge. Okay, so this electrical charge, it is written, it is found, a scientist has found out, it is 1.6 into 10 raised to 9 coulombs. That is what an electron, one small electron in an atom, the charge of that one is 1.6 into 10 raised to minus 19 coulombs. Okay, so because this is the electricity is the flow of electrons, this is how we will learn it, that how much electric current is this, the value to that one. Okay, so one electron has 1.6 into 10 raised to minus 19 coulombs. So to make it into 1 coulomb, how many electrons are required? Okay, so that means 1 divided by 1.6 into 10 raised to minus 19. Okay, that many electrons are required to make that many number of electrons are required to make 1 coulomb. So for example, in this one, we said that it is 1 by 1 electrons going, right? To make 1 coulomb of current, you need 6.2 into 10 raised to 18. Okay, that many electrons are required to create the 1 coulomb of charge. Okay. And no, it's a little bit tough, but just have only this part is a little bit tough. After that, it will get simple. Okay. So now just see that one. What is this 1 coulomb? If I have in one bucket, okay, if I have in bucket was 6.2 into 10 raised to 18 electrons in one, that is called 1 coulomb of charge, 1 coulomb. Okay. If that 1 coulomb of charge passes a point in 1 second. If 1 coulomb passes in a circuit, if it passes that 1 coulomb of charge, that means 6.2 into 10 raised to 18 electrons are passing at that point. That is called 1 coulomb is passing in that one. It has in 1 second. That is called 1 ampere. Okay. So if this much, that means 6.2 into 10 raised to 18 electrons when it moves from one point to another in 1 second. it is called 1 ampere of current is flowing. Okay, remember that we told that there is around in the iron box, we were the example what we looked in the iron box, we said it is 5 ampere of current is flowing, right? That means the 5 times 6 into this bucket. One bucket contains how much? 6.2 into 10 raised to 18 electrons, right? So that's 5 buckets of this one is flowing through that one in 1 second in the iron box which I'm using. You can imagine that many electrons is flowing. Now for in Harita's iron box, it was said that one 6.5 ampere. So that means 6.5 buckets of this electrons were flowing at one point for that iron box to work. Okay, and there was I think in the TV we saw that one, it was 1 ampere, right? In the 1 ampere, so this 1 bucket of that one is flowing in 1 second. So that many electrons are flowing to that one in 1 second for the TV to work. Okay, so let's go back to our this one. So in this bulb, it's only this many 1 ampere is 1 coulombs per second. So let's take the let's take the oven. Okay, 6.8 buckets of that one is flowing for that one oven to work. Iron box 6.5 times. In the fan, in the fan, it is only quarter of that one. Okay, that quarter of that electrons are passing for the fan to work. In the blender, it is almost one bucket of that one is flowing to create that current. Okay, so that is how that many number of electrons are flowing to create the current to create the for that equipment to work. So this is 1 ampere. If it is 2 is passing, it is 2 ampere. If 3 buckets are passing, it is 3 ampere. Let me show you. So if it is 1 coulomb 1 second, 2 coulombs 2 seconds, it is 2 ampere. And if it is 3, it is 3 ampere. So that's what it is meant by ampere. When the number of electrons, that is 1 bucket of that is 6.2 into 10 raised to 18 electrons, which make into 1 coulomb. When flows in 1 second, it creates 1 ampere. Okay, if it is 5 ampere, what happens? It is 5 buckets of that one will be flowing that one in 1 second. Okay, that's what it is meant by when you say the current is that the current indifferent. So in this, for example, in this circuit, when I'm saying at this point 6.2 into 10 raised to 18 electrons are passing in 1 second, I'm saying that one there is 1 ampere of current flowing in this one. Okay, so 1 coulomb means 6.2 into 10 raised to 18 electrons. And what is the charge of each electron? It is 1.6 into 10 raised to 90. Okay, this is what the scientist has given us, that this is a figure which we have to remember that one. For the electrons per charge, it is 1.6 into 10 raised to 90. This is a scientifically proven fact. Okay, that is charge per electron. So if then this many electrons pass through this one, it is called 1 coulomb. And when this many electrons pass, 1 coulomb passes through 1 point at 1 second, it is called 1 ampere. Okay, so 6.2 electrons passes through its 1 second is called 1 ampere. Now, so 1 coulombs per second is 1 ampere. Okay, now this is the question. If 62 into 10 raised to electrons passes through this in 1 second, what is the current to this circuit? We know that 1 ampere is 6.2 into 10 raised to 18 is 1 ampere. So if 62 into 10 raised to 18 electrons pass through this in 1 second, what will be the current through this? You can put it in the chat. How much current, how many ampere is flowing through this one? How much ampere is flowing through this one? Yes, hi, somebody named Hyper. Yes. Is written 10 ampere. Is that correct? That is, if it is 62 into 10 raised to electrons passes through this point in 1 second, what is the current through this circuit? What is the ampere through this circuit? Anyone else? Anyone else? What is the current through this circuit if this is this many electrons? If 6.2 into 10 raised to 18 electrons pass through that, it is 1 ampere. Okay. So what happens if it is 62 into 10 raised to 18? Okay. If I change this one into, multiply this one by 10, what happens? What happens? How much is the current? Hrithikesh also written 10. Is that right? Can somebody else also answer? Meka 620. Okay. Anybody else? Okay. Let me explain once more. If 6.2 in 1 second is 1 ampere. So how much is 62 into 10 when 62 into 10 raised to electrons pass through this is how many amperes? (6.2) into 10 raised to 18 electrons when it passes, it is 1 ampere. How much will be 62 into 10 raised to 18 electrons when it is passing? How many amperes will it be? Avantika, it's also written 10. I want everybody to answer this one. Whatever you think. See, nothing wrong, so that I understand where is the mistake. Okay, put it wherever it is. Mega written 10. Yes. Who else? What will be the current through this one? If 6.2 into 10 raised to electron is 1 ampere, how much will be 62 into 10 raised to 18 electrons when it passing? I got only 1, 2, 4 answers. Shreyas also 10. Okay, what about others? Rachel, Santwana, I can see only few people. Chakki, are you getting it?
Yeah, ma'am.
Yeah. So you can put the answer.
Yeah, okay.
Kirtika, Malavika, Gada. How about you all? Are you getting it? If 6.2 into 10 raised to electrons pass in 1 second is 1 ampere, how much is 62 into 10 raised to electrons when it is passing? How many amperes will be passing through this? Yes, Chakki has written 10. Okay. Okay. So is it okay that it's clear that it is number of electrons? So 6.2 into 10 raised to 18 electrons when it passes, it will create 1 ampere. So if it 10 times of that one, 62 into 10 raised to electron when it passes, it will be 10. It will be 10 amps. Okay. 10 amps. Okay. Okay. Now, next one. If it was 62 into 10 raised to 18, we said it is 10 ampere. So what it will be if it is 31 into 10 raised to 18? Can you guess now? Hrithikesh? Yes. Who else? We know 62 into 10 raised to 18 is 10 ampere. So how much will be 31? 31 into 10 raised to 8. Right? It is just half of 62, right? Half of 62 is 31. So that means it will be 5 ampere of current is passing through this. Agreed? Okay, so this one is 31 into 10 raised to 8 divided by 6.2 into 10 raised to 18. That will make it into 5 ampere. So 1 ampere is equal to how many? 6 into 10 raised to 18 electrons. So 31 will be divided by that. It will be 5 ampere of current is passing through this. Okay, question time. Now, based on this one, we learned the current previously, it is flow of electrons, right? Now we're going to the next one. Current is the measure of. Which one is correct in that one? Force that moves a charge past a point, resistance to the movement of charge past a point, energy used to move a charge past a point, or the amount of charge that move past a point per unit time. Which one is correct? Yes. Yes, Hyper, Shreyas, Ritikesh. Yes, Lakshmi. Yes, good. Avantika. Good. Santana. Yes. Okay. So you get it, right? So the charge which passes a particular time, unit time, is called current, right? Previously we learned it is the flow of electrons. Now we move to the next level of that one is amount of charge, that electric charge, the electrons, right? Number of electrons. We call it in charges. Okay. That moves past a point is called current. Okay. Now this should be simple, I think. Let me see if we can get through this. If a charge of 12 coulombs passes through a computer in 2 minutes, okay, I'm telling you, that 12 buckets, we saw that one, right? If 12 buckets is passing through that one in 2 minutes, what will be the current through the computer? Okay, I know it is a bit tough, so I think I'll go with you along with this one. So let us see. We know that 1 coulomb per second is 1 ampere, right? So we know that it is going 12 coulombs per how many seconds it is? 2 minutes, right? But we have to make it into seconds because we know that coulombs is in, we know that it is coulombs per second is ampere. So 12 coulombs per 120 second. So how much ampere is that one? This is now a simple mathematics, right? You can do it. So 12, Ritikesh is telling it is 12 divided by 120 and yes, 0.01. Yes, Ritikesh, yes, right. Hyper, yes, right. Swantana, yes, right. Okay, so if the 12 coulombs are passing through a computer in 2 minutes, the current passing through that computer is 0.1 amps. Okay. Now, if a current 1.6 ampere flows through an electrical device for 10 seconds only, okay, and to see that how many electrons flow through this device during this time. Okay, we know how much, what is ampere, we know the seconds, we know the coulombs, and we know the electrons. Okay, so don't get confused by this one problem. We'll go through it together. Okay, so the current 1.6 ampere flows through an electrical device for 10 seconds. How many electrons are flowing through this one? Let us figure it out. Okay, so we know that 6.2 into 10 raised to electrons is 1 coulomb, and 1 coulomb per second is 1 ampere. So here we know that it is 1.6 ampere of current is flowing. Okay, so that means 1.6 coulombs per second is flowing. Let us see. So 1 coulombs per second is 1 ampere. So we don't know how many coulombs of current is flowing here. We know that it is 10 seconds and 1.6 ampere, right? So how many coulombs is that one? Can you see how many coulombs is that one? This is just an maths, right? What you will do, how do you find out how many coulombs is that one? Dash divided by 10 is equal to 1.6. So Hrithikesh has written it is 1.16 amps. Is that right? Anybody else? This is simple maths, right? Dash by 10 equal to 1.6. So what is that dash? It will be 1.6 multiplied by 10, right? When it goes to the other side, it will go to the multiplication, right? So it is, how many coulombs is that one? 1.6 ampere of current into 10 seconds. So that is 16 coulombs of charge is flowing through that one. So that means 16 buckets is flowing through that electrical device for this. Okay, but 16 for 1 second. Sorry, for 10 seconds. Okay, so 16 coulombs is equal to, so 16 coulombs is the one. Now, what is the question? How many electrons flow through this device during that time? So we are asking, we know that 16 coulombs is, 1 coulomb is 6.2 into 10 raised to 18 electrons. Now we know how many coulombs is there? 16 coulombs is there. So how many electrons are flowing? 16 coulombs means how many electrons? It is 16 times 6.2 into 10 raised to 18 electrons. Okay. So that means if 6.16 into 6.2, actually you will get approximately 100. Okay. So 100 into 10 raised to 18 electrons are flowing through that circuit. So if a current of 1.6 flows electrical device for 10 seconds, how many electrons flow through this device during that time? So we figured it out. Let us go through it once more. Okay, so first we said 1 coulombs per second is 1 ampere. We don't know how many coulombs are flowing. We know the number of seconds and we know the ampere flowing. So how many coulombs per second is flowing through this circuit? It is 1.6 into 10. That means 16 coulombs of charge is flowing through this one. We know that 1 coulomb is equal to 6.2 into 10 raised to 18. And so how many electrons will be flowing? It will be 16 times 1 coulomb of electron charge, right? 6.2 into 10 raised to 18 electrons, which is approximately 100 into 10 raised to 18. If you go back to our problem options, which is the correct one in this one? It is 100 into 10 raised to 18. So which is the correct answer? Yeah, 99.2. I just approximated that one to 100. Can I know what is the name of hyper? It's a little odd to call hyper. Can you type it? What is your name? So I'll call you by that. Who is chatting has the name hyper. Okay, Navajit. Okay, Navajit. Okay, yeah, it is 99.2, but if approximately we're saying that 100. So which is the option here? Which is the option here in this one? We said that one 100 into 10 raised to 18, right? So that is the 2 zeros are taken to this. It will be the C. Okay, 1 into 10 raised to 20 is the answer. And that many electrons are flowing in this circuit. Okay. Okay, I think this was the toughest part of today. I think remaining will be much simpler. Can a little bit relax because this is charge. It is little bit. You have to just go through it. I think I'll share this material in the website. Go through it and go through this. Maybe simple problems I will share this week onto this one. Go log in and see that one. Simple problems will be see that so that you get used to what is this charge, the number of electrons, and the current. Okay. Now, you know that this is a still river. Water is not flowing. Okay, because there is nothing is forcing the water to flow. But in this one, since there is a slope, already the gravity of this one is allowing the water to force the water to flow. Similarly, okay, in electricity, we said that this is the voltage. The voltage is the force which will allow the electrons to flow. Otherwise, if it is at the standstill, this electrons cannot flow. This is 1 coulomb of charge which is flowing in 1 second. So if this is the voltage, is the force which will allow the electrons to flow in a circuit. Similar like the water flows when there is a level difference and the pressure difference, because it will make the force for that one to flow. Similarly, voltage is the one which will force the electrons to flow. Okay, so now the voltage can differ in different places. It will be for different equipments. You have seen your batteries, right? Sometimes if you have, when you are small, you had the car batteries, right? It will be sometimes 9 volt. So what do you use it for your clock and all in the home? It will be 1.5 volt only. So that it differs. Okay. So this one, if it is 1.5 volt, the pressure of that one is little only. The bulb will be illuminated with less light. Now, if it is 9 volt, it is, the more electrons will flow, that more the coulombs per second will flow. So there will be, the light will be more illuminated because it is having more electrons. So if it is 9 volt battery have used, the light will be more brighter. Okay, so what is a voltage? It's just a definition of that one. Voltage is a pressure from the electrical circuit's power source that pushes charged electrons through a conducting loop or a closed loop, enabling them to do work. So if it is more voltage is there, more current will flow and it will more illuminate. So that is so voltage is the pressure and it is always measured in volts. Okay, so we learned about the current and the charge, that because the current is the flow of electrons, electron is having its charge, electrical charge to that one. So that electrical, that 6.2 electrons, if it is full by that one, it is called 1 coulomb of charge, and 1 coulomb of charge flows in 1 second. It is called 1 ampere. That is what the measurement of current is, 1 ampere. The voltage, it is measured in volts. It is the pressure which will allow for the force which will allow the electrons to flow. Okay. Now you all know that your home appliances, okay, everything is plugged into your electrical plug, right? Your oven, when it is plugged, it works as the oven. When it is heater, that it will produce heat on that one. If it is an iron box, you get that that's also heated, and you can iron your clothes. When the same electricity goes through an electric bulb, it produces light. Why does it happen like that? What happens? It is the same electricity which is going, okay, but the usage is so different. When it passes through your TV, these electrons, you can see the pictures in that one. Or in the fridge, when the current passes through that one, your food gets colder, right? So different, same electricity, it is plugged into the same one. What makes it the difference? We learned about the resistance, right? We said the resistance is restricting the flow of electrons. Is it a bad thing? Is it a bad thing? No, it's not a bad thing. It is that, when the electrons in the flow, they hit that one, it gives the energy. Okay, it gives out, sometimes it gives out a heat energy, or sometimes it gives us an electric light energy, or different types of energies we get it. Okay, so resistance, it is resisting the flow of electrons, but it's not a bad thing. It's a good thing that we use that application for different equipments, electrical appliances, which we use it every day. Okay, so when it hits this one, there is an energy transfer is happening. Okay, and that energy we use it for different application. For the resistance, so there is a loss of energy, the energy is transferred and we can use that energy. Okay, so the resistance, it is always measured in ohms. Okay, so 3 things we learned, right? That what is how we measure the current, we measure in ampere, voltage we measure in volts, and resistance we measure in ohms. Okay, so if it is resistance, is said that it is 1 ohms is the resistance of any circuit. We'll come back to that. Okay, so for example, this is a light bulb. So what happens when the current flows to this one? This is the resistive item in this one. So when the current electrons flow through this one, because of that resistance, what is being offered by that one, it will be converted, and because of the loss of energy, this item, the light bulb, is so designed that one, it will give out light when it is resisted. The electron flow is resisted, it gives out light, and that's how we use the electric bulb. Now for the iron box, this is how, if you cut an iron box or open the iron box, okay, this is what you see inside that one. Okay, so this is the plug which you connect, and when it come inside, okay, this is the wire. There is an, that it will be in the electric circuit should be continuous. But if you see in this one, this is the starting point. Okay, when it comes through this one, but you see there is a gap here. Okay, we'll come back to that one, that why it is not a gap. And then it goes, and if this is close together, okay, if it is attached like this, what happens? The current flows from here, it goes through this, it goes through this one, and it goes through this element. You know, this element is what will heat up the iron box. The heat energy will be produced. So this is a resistive element, and what happens when the current passes through this one, because of the collision of the electrons, it gives away heat, and we use that one to take that heat of that one and to press our clothes. Okay, so now you have seen when you I don't know if you start see if you might be small to start ironing, or maybe some 8th standard are there that you might have it started ironing, right? You see a small knob in front of that one, so it will be said that one, if it is wool, you need to put it at this one. If it is cotton, you need to be turn more. So what happens is, that is the adjustment of this bimetallic strip. Okay, so what happens when you adjust that one, when it is heated, okay, when it reaches at a particular, now for your woolen clothes, it needs only little heat. Okay, so the screw is not tightened much, it is tightened less. So what happens, this is this strip is not that tightened. So what happens when it reaches up to a particular current or the heat, it opens. Okay, it opens. So what happens? The heat will not be increased, which your woolen clothes cannot take it. So this is the bimetallic strip, which allows you the electric current flow through that one. So that what happens when it is opened, current will not flow. It is off. So you will be ironing with the same heat. So once heat is reduced, the bimetallic strip, what happens? It will go back, and then again the circuit is complete. Again the current will flow, and it is heated again. Now if you want it to be heated to the cotton, so what happens? The screw is more tightened. So what happens? It needs more time. It will be more time current will flow, so that once it is heated, only later on when it is that much force is required to remove that to open the bimetallic strip. Okay, so that is with the bimetallic strip, it is adjusted. So what we need to know is in this one is this iron, this filament here, it is a resistive element. When the current passes through that one, it will allow the current, the loss of energy which has happened due to the collision of electrons. The resistance of this material, it will give out heat energy, and we will be using that one. Okay, that is for the iron. Same thing, same different type of application is used for all these equipments. Okay, washing machine, what it is used, it is given through a motor which will make it to run. Okay, and which will allow your electric for this one to rotate and wash your clothes. Fridge, it is converted, it will be used going through a compressor which will work. You know that there's a compressor that you will learn it later on, and it will use the compressor will make this one the cold air, which will make your food and all cold. Okay, so this resistive property of this element is used to make all these elements. So when the current passes through that one at a particular voltage, it is used for different application. Okay, now we learned about voltage, ampere and ohms. Is there a relation between that? That if I increase the voltage, what happens to the current? If I reduce the current, if I reduce the voltage, what happens? If I reduce the ohm, resistance of it, what happens to the circuit? Let us look into that one. Okay, so in this one, see, this is 1.5 volt, 1.5 ampere, and the ohm of this one is 1 ohm. So there is what happens if I change these values? Now, if I change this value to 2 ohms, the resistance of this one, see, if in the previous circuit, this was 1.5 and this was 1. Okay, if I increase this one to 2, if I measure what is the current through this one, it will become 0.75 amps. That is only 0.75 coulombs per second of electrons is passing through this. But here it was 1.5 coulombs per second was passing through this. Okay, when I increase the resistance of it, the current reduced. So we know that when the resistance increased, current decreased. This is the physically we are doing the experiments and figuring it out. Okay, so the current is inversely proportional to resistance. So when the resistance is increased, current decreases. If the resistance is decreased, current increases. What happens if this one was instead of 1 ohm, if I changed it to 0.5 ohm, this might be read as 3 ampere of current. Okay. Now, if I kept the ohms as 2 ohms and I increase the voltage. Okay, previously the voltage was 1.5 and 2 ohms. Now I increased, ohm I kept the same. The voltage, if I increase to 3, okay, when we measure with that ampere meter, we can see the current is increased from 0.7. See, here it was 0.7, right? It is increased to 1.5. So we can find a direct relation. The current is directly proportional to voltage. So that means if the voltage is increased, current is also increased. Voltage is decreased, current is also decreased, right? You remember this, seeing that circuit with the lamp, one is at 1.5, one is at 9. 1.5, the lamp was with only less illuminated, but in a 9 volt, it was more illuminated because the more current is passing through that. Okay, so now who found out this relation between the voltage, current, and resistance? It was the George Ohms. That's how the famous Ohm's law. In electrical, when you start learning it, you will learn the first thing you will learn is the Ohm's law. Ohm's law gives the relation between the voltage, current, and the resistance. Okay, so the current, we said that one current is proportional to voltage and inversely proportional to resistance, right? That's what we learned it here. Current is inversely proportional to resistance and current is proportional to voltage, right? So that's what Ohm's law says. I is equal to V by R. It's directly proportional to voltage and inversely proportional to resistance. So anyway, if you know the voltage and resistance, you can find out the current. If you know the current and the voltage, you can find out the resistance. Okay, so this is the Ohm's law triangle, just for you to remember so that you don't confuse. If you wanted to find the voltage, you have the current and the resistance of the circuit. If you want to find out the voltage, the formula is V is equal to IR. If you want out found out the current, you take the current I here. What is remaining is V by R. I is equal to V by. If you wanted to find out the resistance, resistance is V by I. Okay. Okay. So now you know the formula, right? Now it's the question time. So can you see this one? If it is 1.5 volt and 1 ohm, what will be the current through it? What will be the current through it? Yes, Connecticut said, yes, George Ohms, yes. Hrithikesh is saying 1.5, Meka 1.5. Yes, guys, write it. It's good to be part, then you'll know more when you answer. Okay, everybody's getting 1.5 ohms. That's great. Okay, so if it is 1.5 volt and 1 ohm, the current will be read as 1.5 ampere. Okay, now, if it is, I know that the current through this one is 5 ampere and the ohms is 1 ohm. What will be the voltage of this one? What will be the voltage of this battery? Yes, Hrithikesh, there are few people who are, the others are not answering. It is 5 amps is the current through this one and ohms is 1 ohm. So the voltage is 5 volts, right? Great. It is 5 volts. Okay, Meka, it is written in volts. The voltage is always written in volts and this one is amps. Now, you remember that previously we did it for this iron box, right? We know the power, we know the voltage, right? Now, Can we figure out what is the current of that one? Previously, the current, here it is, power we know, the voltage we know, then the current we figure it out, right? Now, the question is, what will be the resistance of it? Can you answer? What will be the resistance of it? The power is 1400, voltage is 240, current is 6 ampere. So what will be the, you have the voltage and current, right? So what will be the resistance of it? What will be the resistance of it? R is equal to Lakshmi. Lakshmi is writing 40. Is it correct? How did she get 40? Anybody else? Yes, 240 by 6. That is 240 V by I is equal to R. That's what we learned it here, right? R is equal to V by I, isn't it? So R is equal to V by I. So we know the voltage and current. So the resistance is 40 ohm. That's right. Now for this bulb, what is the, we'll find out what is the resistance of it. We found out the current. I've increased the value. Previously it was 24 watt. I made it into 48 watt and 240 volt. The current is 0.2 amps. So what is the resistance of this electric bulb? Can you find out what is the resistance of this electric bulb? Resistance of this electric bulb? It should be 240 by 0.2 amp, right? That means the resistance of this is 1200 ohms. That's why the current is very less in this electric bulb. Now for this TV, what is the current? We said that it is 1 ampere. So what is the voltage? What is the resistance of this TV? Resistance of this TV is 240, right? Okay, get it, resistance is 240. Now, you might have heard about the short circuit, you know, that sometimes fire happens in this one. You might heard, you know, there is a short circuit happened here. Because of the short circuit, the current is, you know, the fire has been caught. You heard about that one in the newspapers or maybe in the TV. Okay, this is some of the news cuttings, which is called 275 in 3 months. Short circuit is the key cause. Okay, this is one of the, it came in May 22nd, 2020. This was in 16th March in Chandigarh. A shop was gutted in sector 23 with a short circuit is a suspect. What is this short circuit? Let us see what happens. So what is this short circuit is? We know that one. If it is 1.5 volt and if it is 1 ohm, the current through that one is 1.5 amps, right? What happens if this resistance, okay, is go to 0.0001 value? What will happen to this current? What happens if this resistance, by any chance, there is a bypass created, you know, somebody puts in some wire or due to some other reasons, these two wires get stuck together and this resistance is removed. What happens if this resistance of this circuit is reduced to 0.0001 ohms? The current through this circuit will be 1500 amps. Can you imagine in the small circuit? It can take only 1.5 amperes. Now suddenly it is that, you know, that water, how it flows through that small pipe, it burst, right? This many the electrons are flowing. Only 1.5 buckets were flowing of the coulombs were flowing in this one. Now it is 1500 buckets of that one is flowing in 1 second. So what happens? This will burst and it will create heat. Lot of heat will be produced. Because of that one, the fire will be caught. So maybe due to the malfunction of the circuits or due to a lot of things, the circuits get, you know, that circuit may be connected in between and the resistance of that circuit is reduced. Because of that one, the short circuit is happening. So you should be very careful when you use your appliances, and this one, the short circuit, you know, that wires and all, always careful. Electricity is one of the best friend, but it's very dangerous too. You have to use it with all the safety measures. Okay, you cannot just wires and all, you cannot just lie it down there. It should be properly kept it. Otherwise, sometimes it may create a short circuit and it will produce a lot of heat and it might lead to fire also. Okay. And next thing, last one I want to tell you about today's class is regarding the electric shock. Okay, we are learning about electricity and all, but be careful. What is, then it will create shock to you. So what is electric shock? So we say that when children not to do that one, right? Not to touch the electric socket and all. You have small babies in your home, you will be seeing their mothers, oh, don't touch that one, don't touch the electric equipments and all, is always saying to the babies, right? Because they don't know. So what happens when an electric circuit is, in the circuit, normally the current is flowing like this. Okay, the current is flowing like this, and then when you are person, this one, there is no problem with that one. But since it's an equipment, it's a man-made thing. There might be a problem with that. Some equipment, some it might. So when you touch that one, what happens? Your body can take the current. When the current passes through your body, the circuit, the closed circuit, which is happening, previously it was happening like this. Now it is happening through your body. So you mean that this many electrons, it is passing through the body. Your body is conducting it. Your body has water. So this one will be flowing through the body and it will be really very fatal. Let us see that what happens. Okay, so that's why it say that one, if we break this one, if we are not touching on the ground, if we are not a continuous, we don't make a continuous circuit, we will not get shock. So that's the reason they say that one, that you know, that you have to wear the slippers, you know, nice slippers, so that rubber ones, so that it is an insulator. It will not, that continuous circuit will not be there. So in this case, this boy, he is wet and he is touching. So he is a good conductor and the current can pass through it. So that's why don't touch with the wet hand. In this one, see, he is with on a carpet, and this carpet will not be make a continuous circuit. For electric current to flow, see that one, it always has to be a continuous circuit. Once it is not continuous, it will not. So this carpet breaks that circuit and it will not, he will be safe. Okay, same thing, this guy, if it is, there is an carpet, so when ironing, make sure that you put an the rubber carpet below you, and then only do the this. Okay, now I'll just tell you what happens with the current. If it is 1 milliampere of current is passing through your body, you will have a small tingling sensation. Okay, but if it is 15 milliampere of current is passing, you will have muscular contraction and extreme pain will be there. If it is 300 milliampere, okay, your heart, you know, the heart is beating by electric pulses, right? So that will all be disturbed and you will have extreme pain if it is 300 milliampere. If it is 1 ampere is passing through it, you know, the current through the TV, it is 1 ampere. Current through the iron box, it was 5 ampere or 6.5 ampere in Hrithika's home. Oh, so it is 5.6. So with 1 ampere, it will burn and permanent damage or death will happen. Okay, so the iron box, if it is 5.5, can you imagine that many current pass, what will happen to you? Will not be there. So bulb, even the bulb, it was 0.1 ampere, right? That is 100 milliampere. 100 milliampere, it will be 15 milliampere, it creates muscular contraction. And 300 milliampere, it cardiac rhythm. So it will be an electric current through that. This one, if you have electric short and electric bulb, it will be having 100 milliampere. TV, you see this one? So this is how we should not very careful in doing this. And this is the last one. Have you seen the crow sitting on this electric line? The current is flowing through that one, right? But they are not getting electrocuted. Why? Have you wondered that one? Why? That if we touch it, we will be dead. But these crows are sitting so nicely on this electric line. So this is, you know, there's a lot of current is flowing through this one. This is very high current flowing through that one, but it's not. But if you see a bat, sometimes you see bats dead on the electric line, right? But it is across this line. But here it is sitting on the same line. Why it is? So why the bat gets electrocuted, but this one doesn't? So let us see what happens. So because for the voltage, I told you, right? The voltage, the current through pass, you need voltage. Okay, you need a voltage difference is required. If there is no voltage difference, the electric current will not flow through that circuit. So what happens in this bird sitting? This is the circuit. Okay, this is, if you represent that one in electric circuit, the bird is sitting here. So bird is sitting on a surface which is of the same voltage. So the electron doesn't pass through that one. The electrons don't pass through that one, so that the current doesn't pass through that one because there is no voltage difference. If it is voltage difference, then only the current. So that is why bird is not electrocuted. Why the person we get electrocuted? Because our voltage here it is different, and where our leg is there it is different. So because of that one, we are in two different electric potentials. So there is a chance of electrical flow. But a bird, if it is touching both of them, it will be, because there is a voltage difference between both, the current will pass and then it will be. So human body in the normal, and the human body, and always your parents say that one, that when you are wet condition, don't touch the any electrical appliances. After you take bath, don't come and switch off your, so with your wet hand. Why? In the dry condition, your body ohms is 100,000. Okay, 1 lakh ohms. But in wet condition, it is only 100 ohms, so that electricity can easily pass through your body. So don't touch it with the wet body. Okay, so that is for today's class. So we learned about the current and the charge, the resistance and its application, right? All the electrical equipments. Then we learned about Ohm's law. What is the relation between current, voltage and resistance? And the resistance, we found out what is the resistance, current and resistance in the domestic appliances. Okay, we learned about short circuit and we learned about electric shock. Right? Anyone, if you wanted to talk?